This example is to find the normal and shear strains along x and y directions for point D with given deformed geometries. Remember that the normal strain is calculated by the length change divided by the orthogonal length in one direction, and the shear strain is calculated by the angle change between two initially perpendicular segments. So the normal strain epsilon x equals to the length change in x direction divided by the orthogonal length in x direction. The orthogonal length is for AD, that is 400 millimeter. And the change of length, we can see that the C moves to a new position, C prime. It has a horizontal displacement of 2 millimeter, and B moves to a new position of B prime. It has a horizontal displacement of 5 millimeter. And the difference between these two displacements is equals to the length change in horizontal direction. So delta Lx equals to 5 minus 2 equals to 3 over 400. This equals to 0.75%. And epsilon y, the normal strain in y direction, equals to delta Ly. And orthogonal length is for CD is 300 millimeter. And the change of the length in y direction, we can see that A moves to a new position A prime. It has a vertical displacement of 2 millimeter. And B moves to a new position B prime. It has a vertical displacement of 4 millimeter. So the difference is 4 minus 2 over 400. This equals to 0.5%. And the shear strain, gamma xy. And we can see initially two perpendicular segments AD and CD, and after deformation it changed to a new angle. Let's call this as theta star. So according to the definition of the shear strain, that equals to pi over 2 minus theta star. And let me call this angle is theta 1 and this angle is theta 2. So this just equals theta 1 plus theta 2. And as we said that this class we're focusing on the elasticity. Elasticity typically have the elastic formation typically have very small strain. The strain is usually on order of 1%. So for these small angles, we know that tangent theta equals to theta when theta is approaching to 0. So then we can calculate theta 1 and theta 2 in this in their triangles. So theta 1 just equals to tangent theta 1. That equals to this 2 millimeter divided by 400 millimeter. 2 over 400. This equals to 0.5%. And the theta 2 equals to tangent theta 2 equals to, so in this right angle triangulars, this tangent theta 2 equals to 2 divided by 300. That equals to 0.67%. So then gamma xy just equals to theta 1 plus theta 2. That equals to 1.17%. So this solved the problem.